and it is something about our formal and running activities in the area of micropollutants removal, and some of them are also applicable, also in our case in the area of zoos, if we will find some important concentration. Maybe in between, I will give you some intro. It's based on our experiences with quaternary treatment on current wastewater treatment plants, which is in line with the current new legislation, a new European directive regarding urban wastewaters and their treatment.
Okay, I'm Dufek, and I'm going to say a few words about micropollutant removal and our experience with quaternary treatment. And as everybody's hungry, I will try to keep it. So, what is our motivation to deal with micropollutants? Our department has long-term experience in wastewater treatment. We are looking for solutions for high requirements on effluents from wastewater treatment plants. And at our institute, there is also advanced material development, like absorption materials as graphene oxide, so on. And the external motivation is updating the European directive, which is saying to remove some specific pollutants. And also the project was supported from Norwegian funds. So what is the current situation with pharmaceuticals? We monitor treatment plants in Lederer, treatment plants for Amazon distribution center in Prague, and also municipal plant near Prague. And we can say that pharmaceuticals are present in wastewater in concentrations ranging from single digits up to tens of micrograms per liter. And in the effluent, there are generally lower concentrations in terms of hundreds of nanograms per liter, and they are highly variable. And key sources are these treatment plants. And so hospitals have different composition and specific composition and higher concentrations of these drugs that you can see in this table here. And these drugs are most observed or with highest concentrations in the effluents. And the reasons are for wastewater reuse. It can help to solve microbial resistance to antibiotics. Also, these substances have impact on aquatic organisms and many more. And also, there's public interest to improve the quality of surface and groundwater. So I will show you some lab tests and our path from laboratory to pilot testing. So these are the tests we were performing in laboratory. First, coagulation to reduce COB. Then the filtration is needed to remove suspended solids. Then some advanced oxidation processes like Fenton with heterogeneous catalysts, which is a method without extra power needed. And also other oxidations like ozonation and UV oxidation with combination with hydrogen peroxide. And also the last step was adsorption tests, the granular activated carbon. And the analysis were performed by mass spectrometer with liquid chromatograph. So just briefly, we used combination of coagulants, polymer coagulants and iron reagent to achieve more, let's say, bigger blocks to better settling, and we achieved up to 40 or 50% of COD degrees. And oxidation processes were performed firstly classic phenton oxidation. As you can see, this is the result from the laboratory tests. And with higher concentration, we achieved higher removal efficiency. And what is interesting also with when we lower down the pH to 5, that's the blue column, we achieved similar efficiency as with 2 times higher concentration. But as we operated pilot units, we realized that there is high consumption of peroxide. So we want to try tests with UV oxidation. And this is the result from the first test. As you can see, there's also the lower times. There's quite active. And also there's a huge difference between those oxidations because we use 5 milligrams per liter compared to 1,000 or 2,000 milligrams. And we wanted to, or the difference is also that you need more electricity for this oxidation. So we want to keep it in lower contact times as possible. So we just tried tests with higher concentration of peroxide, and we achieved almost complete removal of all the pharmaceuticals up to below the detection limits. And then the last oxidation we performed was ozonation, and we achieved higher removal efficiency. Also, COD decreased, but there is the total organic carbon was not decreasing. So we think that the organic compounds are only changing to different types of organics, and it's not completely removed. And I want to briefly show you the results from pilot units. This is the pilot unit in Lederer, and it's composed from sand filtration, then oxidation with heterogeneous catalyst, which breaks down the organic compounds for bioreactor, which was the second step, for deabsorption and biodegradation. And the last step was adsorption on activated carbon. And the flow rate was 25 liters per hour. And this is the results from the pilot unit. And as you can see, like I told you, that the concentration is changing every month, the particular analytes. You can see also the, for example, the clarithromycin, it's antibiotic, and it's decreasing with every month since the winter season is ending. And we achieved high efficiency, and we removed the pharmaceuticals below the detection limits. And there you can see the highest concentrations we measured, and also the lowest possible level we achieved with the pilot unit. And this is the removal efficiency of particular analytes, and we achieved higher efficiency than 80%, which is same with the directive. And
Někdo něco nastíhal, nebo asi nevím. Petře, nesmíš co?
No. To už je.
Slide. Yeah. Yeah, and there's also example from the treatment plan for Amazon, and you can see again different concentrations for example, carbamazepine, which is psychopharmac, and also the strong painkiller tramadol. And you can say that working in Amazon is very stressful. So to conclude, it's economically good to remove suspended fluids and reduce the COD before the quaternary treatment to reduce oxidizing agent, also extend lifespan for the activated carbon, and also it is optimal to test toxicity of the oxidation products from advanced oxidation, because we don't know which substances are forming. And also adsorption is very effective and crucial for the process. And yeah, the concentrations are changing in seasons, months. And that's our further research that we are building another pilot scale at treatment plant in Lederer. And this should be a complete copy of the technological line with flow rate of cubic meter per hour. And we want to test changes in biological treatment to achieve less COD and prepare the water for quaternary treatment. So it should be composed from these steps as I was speaking about. So it's over, and thank you for your attention.
Thanks a lot, Tomáš. I think that pharmacas are interesting, but my question is from the point of view of animals, what compounds should be limited? I'm aware of the one, diclofenac, which is also quite high here measured, but I know there are some information about what should be what should be done and what is not.
We measured or we observed the drugs which is commonly used for humans, and also which is told by the directive to remove. But I don't know what is the similarities with.
I know that I raised this question. I know that the answer is easy.
In fact, that's what I asked before, and I think that we should make that effort. I don't think that anybody has done that in the world.
Yeah.
So there's lots of experience measuring these micropollutants for human, because the origin is not the wastewater treatment plant, the origin are the people.
Yeah.
I always complain, I don't like that sentence.
Yeah.
But yeah, so having the information of the medicines that are used in a zoo, I think that we have to make that effort and select much better the compounds that we want to measure in the zoo. That will be new. And that will be really interesting.
Yeah.
But regarding diclofenac, you mentioned, yes, it is very, very critical and very toxic for some species. It is question for wets. But what I know, especially some kind of birds are very sensitive and very low concentration are toxic. So this is the reason that, for instance, there is no possibility to use treated wastewater for animal enclosures without treatment of this micropollutants.
Yeah, I think that we have these two different views. So can we use regenerated water from municipal wastewater, not because it's so animals are really sensitive? And the other is, how are we polluting wastewater with micropollutants in the zoo?
Yeah.
Yeah, so that's a good question.
Are there some other questions?
I have another one if you understand. I mean, you didn't measure metabolites, although you assume that there's some partial degradation, no? Because you measure the DOC.
Yeah, not that.
Sometimes you destroy the principal compound, but you generate something which is more toxic.
Yeah, it was the purpose of organic carbon to measure, but not any metabolites because I think that there are a lot of them to form.
Generally, a recommendation from hydrobiologists is that there is no sense to measure products. It's the better choice, and it's also applied, for instance, in Germany, Denmark, what I know is evaluation of final toxicity to direct to not to species, but I don't know how to say.
It is very low in general toxicity. When they try to measure toxicity, it's difficult to justify that we are so worried about these compounds because it's very low.
And the problem are the mixture.
That maybe toxicity for animals is different than for.
Yeah.
So there are
They do it with that, yeah.
cumulative effects in you fish.
That is true. But it's very interesting for more for research because there's no clear legislation yet. But for us, it's